Okay, so we are starting lesson 7 of chapter 1 for math 8, and we are still continuing the idea of scientific notation. Now we're looking at how to multiply in scientific notation. So we don't necessarily have to take the numbers in and out of scientific notation to multiply them. So this is what this section will kind of cover. Not kind of, it is what it will cover. So let me get over here to the correct place. I'm going to make sure. Okay, so there's the correct place. So multiplying numbers in scientific notation. And over here we can see the main concept, or what we're going to be doing. Students add, subtract, multiply, and divide numbers written in scientific notation. So that's what we are going to do. So multiplying numbers in scientific notation extends what we do when we multiply product of powers. So we already went through the product of power rules. So what it means is, before, when we had product of powers, and I'm going to kind of go over here, and I'll have 8a times 8. Actually, I can just do the same numbers. So 6a squared. So this is something that we would have seen in product of powers. So I'd go 8 times 6 for my coefficients, and I'd get 48. And then I'd go a times a squared, and I'd have a to the third power. So it's just a very quick review in product of powers. We're going to do the same dang idea on this one. Same one. So what we're going to do is we're going to take those coefficients, the 8 and the 6, we're going to multiply. And you can see they're grouping them right here, and they get 48. And then we're going to take 10 to the first power and 10 to the first power, and we're going to multiply those together. But we're not going to do 10 times 10. We're going to treat those like a variable, meaning that they stay 10. That's our base. Okay, so it's a base of 10 in this case, instead of having a base of a variable. So we have 10, and then just like we did with, if we had a squared times a, we'd go 2 and 1, and we'd add them together. Well, same thing here. We have 1 and 1, so we add them together, we get 2. So it's 48 times 10 to the second power. So it's just a way to combine them without having to expand them and multiply. We can use product of power rules. To express the product in scientific notation, we should rewrite it. Why should we rewrite it? Because this number here cannot be bigger than 9. Remember, we went over that in the last section. If you need to review scientific notation, go back over the last video. But the main idea is that number out in front, it has to be greater than or equal to 1 or less than 10. So it's a number between 1 and 9. It can have a decimal on it, but it can't be 48. That's too big. We need to move that decimal over, so it's 4.8. And then if you notice, they add, so it was 2, now it's 3. Because we move that decimal over, we're making a larger number, 48, into a smaller number, 4.8. So that means we have to increase the exponent from 2 to 3. We're moving that decimal one more time. So that's the only thing. We need to pay attention to that and make sure that we have that piece written correctly. So let's move up here. All right, so we're going to rewrite the following in scientific notation. So they already give us scientific notation. We've already moved this 4 times. So this number is actually much larger. It's 5700, and then we would go 1, 2, 3, 4. There's actually 4 more zeros on here. So this is already a very large number, but we need to fix it even more. And we need to go 1, 2, 3. I need to move it 3 more times. So I have 5.7. Remember, once I have all significant numbers, I can drop off the zeros. Times 10. Instead of to the 4th power, I moved it 3 more times. So it's going to be to the 7th power. Let's see, the next one. So again, we've already moved this decimal twice. It was over here, like this. And we moved it. Now we have to move it again so that we're in front. There's a number in front of the decimal there. So it's going to be 6.022. Remember, this 0 is significant because it's in between 2 other numbers. They're only insignificant, or we drop them off, if it's just on the end of the number. The zeros are the only thing left. So this is the number we're going to have times 10. And instead of -2, we moved it 2 more times. So I need to increase that to 4 to show that I've moved it a total of 4 times. So this is just a practice in moving that decimal. So remember, this number in front has to be between 1 and 9. It can't be 0, it can't be 10, it can't be 48 or 5,700. It has to be between 1 and 9. It can be a decimal, so it can be 9.99. That's fine, as long as this beginning number is somewhere between 1 and 9. I had to erase that. I don't know why I had to erase that. Okay, so dividing numbers in scientific notation extends what we do when we apply quotient of powers. So when we multiplied, and I showed you that up there, that was kind of a quick example, but if I did the same thing here, and let's say I had 16a over 8a squared, I'm going to go a squared like that, you divide the numbers. 16 divided by 8 gives us 2, and instead of adding the exponents, when I'm dividing, I subtract. Remember, if I don't see an exponent, it means it's 1. So 2 minus 1 would be 1, so a to the first power. And again, I don't have to put the 1 there. I would just do that. So this is just reviewing quotient of powers, what we did before. Now we're going to apply that to scientific notation. We're going to divide the numbers. So 2.4 divided by 5, and you can see they've separated it, and they get 0.48. And then they have 10 to the 12th power, 10 to the 4th power, and they separate it again here just so that you can see it. It's 12 minus 4, which is where they got the 8. They're subtracting. So if we're multiplying, you add the exponents. If we're dividing, you subtract the exponents. Again, multiplication, addition, both increase. Division and subtraction both decrease. So hopefully that's pretty easy to keep straight. To express the product in scientific notation, we should rewrite it as, so they actually want us to rewrite it down here. They want us to show this is incorrect. It looks pretty close, but remember, we need to move that decimal place over so that it's 4.8, not 0.48. So it's going to be 4.8 times 10, and we need to fix this decimal place because it was 8. It's actually going to go down to 7 because this is a small number and I'm making it larger. So you have to pay attention to which direction you're going on that one. So when you're moving a large number and you're making it smaller, the number goes up. When you're using or going from a small number to a large number, or just, again, remember, small and large just means smaller than 1, larger than 1, then the number goes down, technically, it becomes negative. So this would be 8 minus 1. We have a negative 1 here because we went from a small number to a large number, so we need to take 1 away. All right, let's scooch down here. Boop. So evaluate each expression. Express the result in scientific notation. All right, so down here we have our constants. We have 3.9 times 2.3. So 3.9 times 2.3. So I've separated those out. And then I'm also going to separate out the 10. So we have 10 to the 2nd power times 10 to the 6th power. So I've grouped my like terms. Here are my coefficients. Here are my powers of 10. So now I quite literally just want to multiply 3.9 times 2.3. You can do that, if you wanted to do it on paper here, that's fine. Just make sure you're paying attention to how to multiply decimals. So we ignore the decimal and we put it in at the end. That's how we multiply decimals. Or you are welcome to use a calculator if you need to on ones like this. So we end up with, let me make sure that I get the correct piece here. 3.9 times 2.3, and we get 8.97. Times 10, so we know this is scientific notation. I need to know what my exponent is going to be. So it's 2 plus 6. I have the base of 10, so I just add the exponents together, and I get 8. All right, so let's do this with the second one. We have our coefficients here. So 4.18 times 9, it's times, not a decimal, times 10 to the negative 4, and 10 to the negative 4. All right, so now we want to multiply these together. So 4.18 times 9. So we end up with 37.62 times 10 to the It's -4 plus -4. So it's going to be -8. All right? So I just combined those together. But what do we have to do? We have to fix this number. This is not in proper scientific notation. I need to move this over one piece. So I'm going from a larger number, 37.62, and I'm going to make it 3.72. So when I'm going from a large number to a small number, or when I'm moving left, this goes up. So it's -8, but I need to add 1 to it because I need to go up 1. So it's going to be 3.762 times 10 to the -7th. So it's still -7. That's still a very small number, but I had to go up 1 to show that I moved that decimal. All right, let's look at the quotient rules here. So we're going to divide 1.14 and 4.8. And then we're going to divide the power rules here. So first, let's do this one. We have 1.14 divided by 4.8, and we get 0.2375. So that's what I got from this piece here. Times 10, we need to know our exponent. So remember, when I'm dividing, it's the top exponent minus the bottom exponent. So it's 6 minus -6. They're being a little tricky on this one, aren't they? So they want us to pay attention that this actually turns into a positive. Whenever I have minus negative, that's going to be 6 plus 6. It means this is in the wrong place. It should actually be on the top. And again, we went over negative exponents a couple sections ago. So if you need to, you can always watch over that video again. So this is going to be to the 12th power. But we need to fix this. This can't be a 0. We need to move this over so the 2's in front. So we're going to end up with, and I'll just write the answer over here since I wrote on that line, 2.375 times 10. I need to indicate that this is a small number and I'm making it a little larger, or I'm moving to the right. That's another way to think of it. So this needs to go down by 1, or however many spaces I moved it. In this case, just 1. So it's going to be 11. That's my new exponent. So here is my scientific notation there. All right, if we look at the next page, I believe we're just going to be doing addition and subtraction now. All right. So in this case, we have when adding or subtracting numbers in scientific notation, the powers of 10 should have the same exponent. So this is a case where we're actually looking for kind of more like terms. So if we had 2a and 5a, we can add these two together. They have like terms. They both have the same variable. But if we had a case where it was 2a and 5a squared, well, now they're not exactly the same anymore. So this is the same idea what we're looking at here. When we're doing addition and subtraction, we need the power of 10 to be the same, just like the same variable. We treat that power of 10 kind of like a variable. So when we're looking at this, what we want to do is change it so that we do have the same variable. So if we have one that's, or not variable, I'm sorry, the same exponent. If we do have one that's not the same, so we're starting off right here with one that is not the same. And it's showing you on this side, we want to move the decimal to the left 4 places because I need to go up by 4. And in order to go up by 4, it means I need to move to the left 4 times. 1, 2, 3, 4. 1, 2, 3. I put zeros in there, put a 0 in the front. So now I have 0.000, 3 zeros. So I've corrected that number times 10 to the 10th power. And now I can add this piece to it because now they're both in the same position. Okay? So I just need to make sure that these pieces, and I'm going to circle them in red here, we need to make sure that those are the same. And if they're not the same, we need to make them the same like this. We need to fix it so that they are, in fact, the same. So now I can add together these two numbers. If I add this number and this number, the coefficients, then you can we may have to go back and kind of refix the issue a little bit here, but we can add the coefficients together. So I'm going to go 1, 3, 3, 4. I'm going to line up my decimals, 1, 2, 3, 8, 6, 4. Make sure you line up your decimals when you're doing addition and subtraction with decimals. And we just add straight down. So we end up with 4, 6, 8, 4, 3, 3.1, because really everything just comes straight down. Nothing actually gets added together because of the different columns that it's in. And then we have times 10 to the 10th power. So this doesn't change. We're just adding them together. So this is not the power of a product rule where we're adding the exponents together. We're literally just adding two numbers together. So this exponent, the power of 10 and the exponent stay exactly the same as they were. All right, so let's go ahead and take a look. Whoops. I need to get that changed. I'm too used to doing it the other way here. All right, so let me scooch over here. So we're going to do the same thing on this one. So we want to make these match. So if I'm looking at, and I'll just write it down here, we want this to go up by 11. So if I want this to go up, it means I need to move this 1, 2 times. Okay, so now I have 9.5 times 10 to the 11th plus 0.063 times 10 to the 11th. So I fixed them. Now these match. So all we have to do, I know it's going to be 10 to the 11th unless I have to fix that. That may come up where you have to move the decimals to make sure that that number out front is 1 to 9. But now I can just line these guys up. Just make sure you line up your decimals when you're doing this. And I'm just going to add straight down. So I have 3, 6, 5, and 9. Nothing really got added. It just kind of all drops down. It is being added, but nothing lined up. So it all just dropped down. So I have 9.563 times 10 to the 11th. All right, this next one, we want this one to go up 2 more, which means I need to move this 2 times, like that. So now I have 1.03 times 10 to the 9th power minus, oops, 0, dang it, hopefully I was writing the number correctly, 0.047 times 10 to the 9th power. So now I can line these up, and I need to make sure I line up my decimals correctly. So these should be right in line with each other, and I'm just going to subtract straight down. So now I have to pay attention. This isn't just going to be 7. I have to borrow, and I get 3. And then I'm going to have to borrow again and again, and I get 10, borrow, 9, 12. So these are just kind of going back to doing that subtraction by hand. 12 minus 4, we get 8. 9 minus 0, we get 9, and we bring that decimal down, and it's 0. We have to fix this because it would be 0.983 times 10 to the 9th power. But remember, we can't have a 0 on the front. So I need to move this over. So I'm moving a small number. I'm making it larger. It was 0.9. Now I'm going to have 9.8. Or I'm moving to the right, so I need to take one away. So it's going to be 9.83 times 10 to the 8th power. Okay, so let's look at this last piece here. We have 87,100 minus 6.34 times 10 to the first power. So I moved this over 1. So I could just move this over and take it out of scientific notation, like this. So now it's not in scientific notation anymore. It's 63.4. And I can subtract these and then put it back into scientific notation. Or I could very well put this into scientific notation. Really, there's 2 options here. Totally kind of depends on what we want to do there. I think this is a little easier to just go ahead and subtract these guys. So we have 63.4. And I don't know where my pen tool went. Where's my pen tool? There it is. Let's see if I can erase this without taking too much away. And that's going to be 0. So just make sure you're going to have to go through and borrow a whole bunch here is the big problem. So this would be 10, but I'm going to borrow and make it 9. 10. I'm going to borrow and make it 9, 10. So I have 6 point. Now 9 minus 3 is 6. 9 minus 6 is 3. 0 comes down and 87. So 87,036.6. And you can always confirm that on a calculator. No big deal. Just to make sure you've subtracted correctly. So the problem with this one is this is just the number because I took it out of scientific notation. I need to put it back in, so I'm going to go 1, 2, 3, 4. I'm going to move it 4 times. So it's going to be 8, 7, 0, 3, 6, 6 times 10, and I moved it 1, 2, 3, 4 times. So I have to make sure I put an exponent of 4 to show that I moved that 4 times. All right, so that is section 7. I will see you in section 8.